All right, number 25 here. Next part of that, the last part of it, actually will be all of our simplifying of radicals. So I'm gonna quiz you up, test you up on that. You guys have done well there. Let's just make sure everything goes fine. 45, take your tree off to the side. Okay. And when I get that, I get a 9 that's gonna be hiding there. So when you do that, 9 is 3 and 3. So I bring out that. The answer should have been 15 square root of 5. 144 is perfect. It is 12, and 4 times 12 is just 48. Who cares if there's variables in there? We did this before. Okay, 48. I rewrite the prime factorization of 48. Now, I'm sure most of you can kind of do this in your head by now, but I'll just go ahead on this one, write everything out. And x to the 7th, remember we said we want to rewrite that as a even exponent, and there will always be one left over because we're looking for pairs. So we do that. Pair of 2s, pair of 2s. So I got a 2 and a 2. Underneath it's going to stay a 3. And at x to the 6, we can see that we have 3 pairs, so x to the 3rd. And in that y squared, we also have a pair. Clean that up. There you go. Multiply. First we multiply, and then we simplify. All right, so whatever you need to do to get yourself going there. 60, my prime factorization, I see a pair of 2s. So that's going to be negative 16 square root of 15. 29, first we multiply. And then I realize 100 appears. It is perfect. And the square root of 100 is 10, negative 50. Okay, adding and subtracting. In order to add and subtract, I gotta have like radicals, which I do not. So unfortunately, I gotta take both of these off to the side. 27, 3 root 27, simplify. Negative 2 root 12, simplify. All right, 3 root 27. When I do that one for me, whoops, I'm gonna end up with a 9 root 3. And then negative 2 root 12, I'm gonna end up with a negative 4 root 3. Check your work. I believe that should be it. Now we have like terms. 9 minus 4 gives me 5. Remember, it stays as root 3. All right, next one here, 31. Okay, first thing I notice is I've got some like radicals to start off with, and they're exactly the same. They're opposites. So those are going to cancel out completely. Nothing remains. Now, 3 root 28, I'm going to try to simplify down, and I can, to negative 6 root 7. Happens to be like radical with 5 root 7, so negative 6 plus 5 is negative 1 root 7. All right, last one here is a cubed root. So as I do my prime factorization of 24, 2 and 12, 3 and 4, 2 and 2, because it's a cubed root, I am looking for groups of 3, triplets. For every group, 1 comes out, and 10 cubed root of 3. All right, last one here. Good old perimeter and area of a square. 5 root 3 all around. All right. So with that, perimeter, add up all sides. We have 4 sides that are 5 root 3. So the simplified expression is 20 root 3. Area is squared, the side squared. So 5 root 3. So 5 root 3, you better put that in parentheses and square it. So when you take 5 root 3 squared, use your calculator, or you should be able to do it in your head. 5 times 5, root 3 times root 3, and 25 times 3 is 75 units squared.